Alright, so today we're going to talk about filter tuning with Betaflight 3.3.0-RC2. Okay, after flashing your board over to Betaflight 3.3.0, we're going to go ahead and connect. Now keeping in mind that we are running release candidate, so there's some inherent change that's going to occur here between now and the stable release, and also that you're participating in beta testing when you're using this firmware. So do keep that in mind. We're going to go into the configuration tab, and I'm first going to talk about what I believe the bulk of people are flying is either 4K 4K or 8K 8K gyro and PID loop frequencies. We need to keep in mind that this new filtering is primarily targeted at enabling people to fly and have a filtering available to fly 16 kilohertz and 32 kilohertz sampling modes. However, we can use this as a substitute for some filtering that's within the software already in these, what I will say, classic, or what will be in 6 months lower PID loop and gyro frequency rates. After we get our board kind of set up again, because you're going to have to redo all your settings, we're going to go down and tick on the dynamic filter. So that's a mainstay that is in both recommendations. Either the lower, the 4K 4K, or 16 or 32 kilohertz is to have dynamic filter turned on. So go ahead and tick that on. If you're flying the higher rates, the 16 and 32, it's recommended to use one or multi-shot over a D-shot, because a D-shot takes up a lot of CPU cycles, so it enables basically your processor to have a little less load. Okay, under the PIDs tab, we're going to go to the filter settings, and in the filter settings, this is where we kind of split off, and the 1632 kilohertz folks are going to have different settings than the 8 and 4K kilohertz folks. In either case, unless you have an extremely noisy quad, which we'll look at in a second, you should be able to turn off your static notch 1 and 2. We turned on the dynamic notch, so that's really replacing these static notches. If you are running 8K and 4K, and let's take a look at the graph here, you can see that the noise attenuation for the new BQRC F2 filter is essentially the same from 1000 kilohertz down, and when you're running the lower PID loop frequencies, you are, most of your noise, your motor noise is, for anybody, is going to be between 150 to 350 at the most, and then you're going to have some bass higher noise, from 350 up to 600-800 hertz, and you're not going to really have anything over 1000. However, the higher PID loop frequencies, the 16 to 32 kilohertz, you're going to have some noise up here as well that you need to attenuate. So for this, what we're going to do is turn off the PT1 filter for the lower kilohertz ranges, and then use the BQRC filter in its stead. So to do that, we're going to go back into Betaflight. We're going to set the gyro low pass filter to 0 and hit save. We're going to go to the CLI command and type get low pass, and you can see this new filter's cutoff is the stage 2 low pass. So again, to facilitate 16 and 32 kilohertz sampling, the intent is to have a two-stage low pass filtering. The stage 1 is the classic, and the stage 2 is the new. However, we're turning off the classic in the 8 and 4K, and we're going to turn on stage 2. So we're going to type in set gyro underscore stage 2 underscore low pass underscore hertz equal to 90, and type save and hit enter. Okay, so what did we do there? Essentially, let's pop over to Blackbox and let's look at a spectrum trace. And what we really did there is turned off our stage 1 low pass filter, but turned on our stage 2 to be at the same hertz range as what the stage 1 used to be. What's that going to produce? essentially the same result at low frequencies. However, around 500, 300, 500, it does slightly attenuate a little bit more noise. It does have more latency as well. Phase delay is associated with latency. So give it a shot, see if it's any better. And then the classic guidance on setting up your D-term filters is how it was for Betaflight 3.2. And you first want to fly this. Make sure your motors don't get hot. If they're not, you can go ahead and try turning off your D-term notch filter, static notch filter. Fly it again. If the motors don't get hot, then you can try to change this to PT1. Be very cautious on that. Make sure you fly it, very briefly, 5 to 20 seconds, just in a nice hover. Land it, feel your motors right away. And then if they're not hot, fly it a little bit more aggressively, and then kind of just ramp it up from there. Just be cautious so you don't smoke a motor. If you are running 16 or 32 kilohertz sampling, you would want to leave the low pass filter, the classic low pass filter, on. So you'd set that back to 90. And then what you really want to do for the new BQ-RC filter is you're going to essentially need to go into Blackbox, run a trace on that, and see what your spectrum, where your peak motor noise is at. So how to do that? What you first need to do before you record a Blackbox log is set your debug mode to notch. So we type in set debug _mode equals notch. Type save and let it reboot. From there, you're in your Blackbox tab. You're going to set your sampling rate and then where you're going to record the data to. Note that if you're running the same gyro and PID loop frequency, which I recommend, you would set this, at least for the 8K and 4K gyro and PID loop frequencies, you'd set this to 1 kilohertz. That's as high as you need to log. If you're running higher PID loop frequencies, the 16 and 32, you're going to have to bump this up to go 4K or even higher, so you can see that range, probably up to, I would say, 10,000 hertz. So go ahead and record a log. Then you want to download and install Blackbox Viewer. And you can get that on the Betaflight repository or CleanFlight. I've actually noticed that you get a little bit better results with less missing header fields with the CleanFlight version of Blackbox. They're both versions are 3.0.0-RC2 versions of Blackbox. It just looks like CleanFlight was cleaned up a little bit more. So that's what I'm using here, and you can see it's 3.0.0-RC2. And if you go into the header file here, the differential, so you can check it out for yourself, is that, like I said, here I'm getting the correctly reported anti-gravity gains, and also it shows that if the dynamic filter is turned on or off, and it also is showing less missing header files down below. So that's good. This is actually an old trace, a 3.2.1 version of Betaflight, but here's a newer one, 3.3.0, and go back, and again you can see that there's less missing header fields. If you go into a Betaflight one, it's going to have more missing header fields. So a little tip there. So anyways, using the solder trace because it's a nice sample, you can see my peak motor noise is 276 hertz. So to run that debug notch, what you would need to do is go up, hit a custom graph, go down, select the field, just pick debug notch. It will add the other ones in automatically, and you can see it's right here. And then you click this spectrum analyzer on the right hand side. Before you do that, you do need to make sure you clip off if you bounced or there's any external forces on the quad, that you clip them off. You can see in this trace, if I log this and just keep this down in the lower left, and you can see I get a much different result if I change my output to show those bounces. So if I turn my output or my endpoint, so you can see if I back up a little bit and don't clip off the end of my flight, you can see there's a lot of different result in the spectrum analysis. So if you have spots where you're landing and hitting the ground, or there's any external forces mid-flight, you got to clip that out of your log. You can't really do it in the middle, but if it's in the very beginning or the end, you can use the I and the O keys to clip off the back end of the log or the front end of the log. So I'm going to go ahead and clip all that back end data off of there, and you can see now I get a much better result, or more accurate result actually. So I'm going to expand that just to look at that here. You can see my motor noise, my peak motor noise 278. Some guys are saying that you want to set your BQRC F2 cutoff frequency right on top of that, so maybe 275, 270. I'm more of a, you should set it near the beginning of where that's starting to ramp up. So if you set the cutoff right on top of the peak motor noise, it's going to attenuate it by half. However, if you set it slightly behind it, you're going to attenuate this noise by half, and then it's going to be a little bit more. It's a pretty shallow curve. It's going to be a little bit more attenuation of your peak motor noise. So play around with it, figure it out for yourself. But you're going to set at least 275 or earlier, maybe 270 or 250, something of that nature. And so again, we'd come back in the Betaflight to do that. And one last thing on that, make sure you look at, that was the roll axis, so make sure you're looking at your pitch axis and your yaw as well. You can see my pitch has a little bit more noise. It's a little lower, so now it's 263. So you can see, you might want to push that back a little bit farther. I'm going to go into Betaflight, type in get low pass again, and then we're going to type in set gyro underscore stage 2 underscore low pass underscore hertz equals 2. I'm going to do 260 in this example, and save. Going into the PIDs tab again, I would say the same applies as we discussed before. Go ahead and fly it, then go fly it and turn off your D term notch, see if your motors are hot. If not, then go fly it again with your D term low pass filter set to PT1. Again, be very cautious when you're making this change, and make sure you're not going to smoke a motor or they're not overheating. Keeping in mind that if you can, and maybe something to try is to turn off the original low pass filter. Essentially, that's the experimental part. The jury's still out on what the best filter settings are for the different ranges, so your feedback is appreciated. What you could try doing here is, again, following the same advice of the 8K, 4K, and just slide that back to the 100 hertz range. It really varies based on how noisy your quad is, and always keeping in mind the least amount of software filtering that you can set for the amount of noise level your quad is, the better. You want to get your filter set up first with moderate, maybe your motors are starting to getting warm, then that's when you want to start attacking your PID tuning. Keeping in mind that as you keep pushing D term up, your motors might start getting hotter. So then if you're pushing D term up and they start getting hotter and you're still getting bounce back or other things, then you might need to change your filtering or look in the Blackbox. It's really, without Blackbox, it's a lot of guessing. With Blackbox, you can kind of see what's going on under the hood and attack it directly. Links below on the different spots you can download Blackbox Explorer, either the Betaflight version or CleanFlight version. Also, links in the video here on the upper right on some other videos I have on holistic understanding of filtering in Betaflight, and or a review of Release Candidate 1 and Release Candidate 2, or actually a build prior to Release Candidate 2 that goes into some more depth on the filters, what types they are, the different graphs, kind of talks about these graphs in a little bit more depth. And finally, just to touch on this, this is the filtering sequence. So as you can see, these are the different debug modes. You can pull out your notch data here. This is prior to the stage 2 low pass filter, which is the new BQ-RC2 filtering. And it's going down through. We turned off the static notches, and then this is the classic. So stage 2 is stage 2 because you can set it to a higher range. That's the intent for higher gyro and PID loop frequencies. Stage 1's lower range for lower gyro and PID loop frequencies. Again, they're primarily the same on the lower range. It's on the higher ranges that it changes. And then this is your D-term filtering, which is after the PID loop does all its calculations, not prior. Okay, everybody, thanks. I hope this helps.